Hello everyone. Today we are going to start our session with case study on application of eigenvalues and eigenvectors. The case study is eigenvalues and eigenvectors via decision thinking, that is population model with the Leslie matrix. We are introducing the type 5 problem and decision thinking. Eigenvalues, eigenvectors satisfying say A B equal to lambda B for a square matrix A. Type 5 problem involve advanced applications such as population growth and dynamics eigenvalue with respect to growth rates, and eigenvectors indicate stable distribution. So the design thinking stages of the following: empathize, define, ideate, and prototype and testing. We have to see one by one, step by one. The case study is by using Leslie matrix to model population growth across the age groups. The empathize is the for user defined ecologist studying population dynamics of species. For this content, the model population growth across three ages, that is three age groups, one as juvenile, adult, and elderly, to predict long-term trends, that is the population growth. So the needs, what are the needs? Determine the population growth rate, stable age distribution to inform conservative strategies. The main goal is using eigenvalues and eigenvectors to analyze the Leslie matrix. The next thing is define. The case study problem: find the eigenvalues and eigenvectors of the Leslie matrix with three age groups. So the given Leslie matrix is 0 to 1, 0 0.5, 0, 0, 0, 0.3 and 0. A1J is the birth rate. The age groups are 2, 3. J equal to 2, 3. Here AI minus 1 survival rates from age group 1 I to I minus 1 to I. The next thing is dominant eigenvalues gives the long-term growth rate. Eigenvectors gives stable age distribution. Ideate. Compute eigenvalues to find the dominant growth rate. Find the corresponding eigenvector to determine the stable age distribution. Consider numerical methods by large matrices, but use direct computation for this 3x3 matrix. Interpret the result, guide conservation, focus on age group with high influence on growth. Next, we have to see the prototype. In step 1, form the characteristic equation. Same, A minus lambda I equal to 0. That is determinant of A minus lambda I equal to 0. So here the identity matrix I, and compute A minus lambda I, lambda minus lambda to 1, 0.5 minus lambda 0, and there is 0, 0.3 minus lambda. Step 2, compute the determinant of A minus lambda I. So calculate determinant of A minus lambda I. We have equate with third row, so and also equate with 0. By the characteristic equation is lambda cube minus 0.3 lambda squared minus lambda plus 0.5. So we have to determine determinant of A minus minus lambda I, that is determinant of minus lambda I value. So we have to equate the third row, expand that third row, determinant of this row of the cofactor of the third row. We have to give the equation minus lambda cube plus 0.3 lambda square plus lambda minus 0.15. We have to equate 0. So the characteristic equation, we find the characteristic equation. Next, solving the eigenvalues by cubic equation. Solving cube equation, so we get the lambda value, that is eigenvalue. Therefore, lambda equal to 0.5. Next, we have to find eigenvectors for lambda equal to 0.858, because here the lambda value is 0.858 is the eigenvalue, dominant eigenvalue, which is the approximate one. So substitute lambda equal to 0.858 in A minus lambda I. We have this matrices. So we get the matrix and solve the matrix with vectors x, y, z. So the equation becomes we get the x, y, z value x equal to 1.716y. So in this term we have y equal to 0.878. The dominant eigenvalues lambda equal to approximately equivalent to 0.858 less than 1. That is, population is declining. So eigenvector, corresponding eigenvector 4.91, 2.86 and 1. Stable edge distribution is the eigenvector. Next, testing by verification. So substitute the lambda and the vector, that is eigenvalue and eigenvectors. We are verifying the values. Substituting A, the value of given less than matrix, we get 4.213, 2.43453, 0.858. So the total, by design thinking approach, we have empathized with ecologists and defined the population problems, ideate the solution, then prototype the calculation and test the result for conservation insights. Thank you.